Hello there, and welcome to the Sleep Journal. Tonight, we are going to talk about the loneliest objects in the entire universe. Not a star, not a galaxy, but planets. Planets with no sun. Not orbiting any star at all. No daytime. No sunset. Just darkness, stretching on forever in every direction. Astronomers call them rogue planets. Sometimes, orphan planets. Worlds that were cast out of their own solar systems billions of years ago, and now drift alone through the space between the stars. Nothing to hold on to, nothing to circle, no one waiting for them. Picture a planet close to the size of Earth. Its surface might have mountains. It might have oceans, long since frozen solid, and somewhere deep beneath that ice, there might still be a little warmth left over. But above it, the sky has no sun. No star close enough to light anything up. Only tiny points of light far in the distance that look the same every single night because they never rise and they never set. There is nothing to mark the passage of time on a planet like that. No day, no season, just one long night that never ends. Before we settle into this story, if evenings like this help you unwind, feel free to like, subscribe, or leave a gentle comment below. It helps other tired minds find their way here. But for now, there is nothing you need to do. Let your jaw unclench. Let your shoulders drop. Let your breathing slow down into something easy, like the breathing of someone who has already let the day go. And as your mind begins to soften, join me. Let us begin. Scientists estimate that the number of rogue planets in our galaxy may actually outnumber the stars. Some studies suggest that in the Milky Way alone, there could be hundreds of billions, perhaps even trillions of rogue planets. That is a hard number to picture, but it means that scattered among the stars we see at night, there are countless worlds drifting in the dark that we will never see at all. They do not glow. They do not reflect the light of any nearby star. They simply exist in absolute darkness, across distances that the human mind can barely hold on to. To put this in perspective, our own solar system has only 8 planets circling a single star. But if you added up every star in the entire Milky Way, along with every planet that orbits them, that number might still be smaller than the number of rogue planets drifting freely out there. It is a strange reversal of how we usually picture the universe. We tend to think of space as something organized around stars, like bright islands scattered across a dark sea. But most planets may not belong to any island at all. They are simply fragments drifting through the dark ocean of interstellar space, anchored to nothing anywhere. Think about how strange this really is. Every planet you have ever heard of shares one thing in common. It orbits a star. That has always been part of the definition of what a planet is. But rogue planets break that definition entirely. They are planets in every physical sense, but they belong to no star at all. They exist in a category our language was never quite built for. Not a star, not a moon, simply a planet on its own, floating through the vast emptiness that separates one solar system from another. To understand why these planets wander alone, we need to go back to the moment a new planetary system is born. When a star forms out of a vast cloud of gas and dust, planets slowly take shape around it too, from that same material. In those first few million years, a young system is chaotic. Many newly formed planets are crowded into a small space, colliding, pulling at each other with gravity, and sometimes throwing each other off course. This is not a gentle process. It is more like a long struggle, lasting millions of years, as planets fight for a stable orbit. During that struggle, some unlucky planets get flung out of the system entirely, by the gravity of other planets or by the star itself. They reach a speed high enough to escape that star's pull forever. And from that moment on, they become rogue planets, no longer orbiting anything, just drifting on momentum alone through the space of the galaxy. Astronomers call this phenomenon gravitational instability among multiple bodies. When 3 or more objects interact through gravity within one system, the outcome is often impossible to predict over long stretches of time. This is one of the oldest and hardest problems in physics, known as the three-body problem. Even with today's most powerful supercomputers, predicting the exact path of 3 gravitationally linked bodies over millions of years remains close to impossible. The smallest difference in starting conditions can lead to completely different outcomes after enough time has passed. This means that a planet getting ejected from its system is not something that can be calculated in advance with any certainty. It is the result of a process that is almost random, built up over millions of years of small interactions, until one moment strong enough finally pushes a planet out of its stable orbit forever. Scientists believe this process is not a rare event at all. In fact, it may be a normal part of how every planetary system forms. When researchers simulate the birth of a solar system on a computer, they usually find that at least one, sometimes several planets get thrown out before the system settles down. It is a bit like watching a crowded room of strangers, all trying to find their own personal space, bumping into each other, until eventually most find a spot, and a few get pushed straight out the door. Those few become the rogue planets. And once outside, they never come back. There is no return journey from interstellar space back into a solar system. The escape is permanent. The planet keeps the velocity it had at that final encounter, carrying it forward in a straight line, essentially forever, only bending slightly under the gentle pull of the galaxy's overall gravity over unimaginably long timescales. If this is true for most planetary systems in the galaxy, then the number of rogue planets created this way would be enormous. Every star we see may have once contributed one or two planets to the vast cloud of lonely worlds drifting across the galaxy right now. Finding a rogue planet is much harder than finding a planet orbiting a star. When a planet circles a star, astronomers can watch the star's light dim slightly each time the planet passes in front of it. That method is called the transit method. But a rogue planet has no star to block. It gives off no light of its own. It simply drifts in complete darkness and cannot be observed using those ordinary methods. So scientists use a different technique called gravitational microlensing. This technique relies on a principle that Albert Einstein predicted many years ago. When a massive object, like a planet, passes in front of a distant star from our point of view, the gravity of that object bends the light of the star behind it. This causes the star's light to brighten briefly for a short period, and then return to normal. If astronomers watch closely enough, for long enough, across enough stars, they can catch these brief and unusual flashes. And from that, they can infer that an object with planetary mass just passed by, even though they never see the object itself directly. This is one of the most delicate techniques in astronomy. It is like spotting a shadow passing by, just by watching a tiny bend in starlight for a fraction of a second. These microlensing events are extremely rare and extremely brief. An event caused by a low-mass planet might last only a few hours. That means astronomers have to watch hundreds of millions of stars continuously for years, just for a chance to catch a handful of these events. Large survey programs, like the one called OGLI, based in Chile, have spent decades doing nothing but tracking tiny changes in brightness across hundreds of millions of stars near the center of our galaxy. And from that mountain of data, they have found evidence of many rogue planets. Worlds we will never see directly, but that we know are out there, drifting in the dark between the stars. What makes this especially remarkable is that each microlensing event happens only once and never repeats. A rogue planet passing in front of a distant star does so a single time in the entire history of human observation. After that moment, it continues on its way, and will never create a similar event again, at least not within any time frame a scientist could ever witness. This makes confirming a single microlensing detection particularly difficult. There is no way to look again and be certain. Researchers must rely entirely on the precision of the data captured in that one fleeting moment. There is no repeat performance, no second chance to double-check the measurement. This is quite different from most other areas of astronomy, where a telescope can simply point at the same object again tomorrow night and confirm what was seen. With microlensing, the event is gone the instant it ends. All that remains is a curve on a graph, a record of brightness rising and falling over a period of hours, or sometimes just minutes. From the shape of that curve, scientists can work backward and estimate the mass of whatever object caused it, along with a rough sense of how far away it was. One of the most astonishing things about rogue planets is the sheer scale of the phenomenon. For decades, astronomers only thought of planets as objects tied to a star. But as microlensing research has advanced, a different picture has slowly emerged. A study based on data from the survey program called MOA in New Zealand, estimated that there may be more Jupiter-sized planets drifting freely than there are stars in the galaxy. If that is true, then for every star you see in the night sky, there could be one or more similarly sized planets drifting somewhere, with no light and no attention from anyone. That number remains debated among scientists. Later studies offered lower estimates. But even the most cautious ones show that rogue planets are not a rare phenomenon. They may be a normal and common part of our galaxy. This changes how scientists think about the universe. In the past, people imagined the galaxy as a collection of solar systems, each with one star and a few planets circling it, similar to our own. But the real picture may be more complex. Scattered between those star systems is an ocean of lonely planets, drifting freely, making up a significant portion of the galaxy's total mass. They are not seen. They are not named. They are not marked on any star chart. But they are there. Billions, perhaps trillions of worlds, each with its own history, each perhaps once having volcanoes, each perhaps once having oceans, each perhaps in some distant moment having circled a star under warm light. And now, all that remains is darkness and drifting, with no destination and no ending point, only a journey stretching into infinity, through the space between the stars. The MOA program, short for the Microlensing Observations in Astrophysics Experiment, was carried out through a collaboration between Japanese and New Zealand astronomers. It was originally designed to search for dark matter using gravitational lensing, but along the way, scientists realized that the same technique could be used to detect much smaller planets drifting through space. Results from the 2011 study by the MOA team shook the astronomical community when it reported that the number of Jupiter-sized rogue planets could be twice the number of stars in the galaxy. That finding sparked considerable debate at first, because it challenged existing models of how planets form. But over time, with more data gathered from other surveys, the overall picture has become clearer. While the exact number remains up for debate, the existence of a large population of rogue planets is now widely accepted as a normal part of galactic structure. Some researchers now believe that smaller rogue planets, closer to the size of Earth, may be far more common than the larger Jupiter-sized ones, simply because smaller planets are easier for a young system to eject. Let us imagine standing on the surface of a rogue planet. There is no sun to mark the morning, no sunset to mark the evening, only a sky that is permanently black, dotted with faraway stars, tiny points of light that never move in any meaningful way over the course of a lifetime spent watching them. The temperature on such a planet would be extreme. Without sunlight to warm the surface, temperatures could drop close to absolute zero, only slightly higher than the background temperature of the entire universe. Any gas that once existed in the atmosphere, if there was one, would freeze and fall to the surface like snow. Even nitrogen gas, which makes up most of Earth's atmosphere, would liquefy and then freeze solid at such extreme temperatures. A rogue planet could be covered in a thick layer of nitrogen ice, snow made from gases that on Earth we only know as the air we breathe every day. But interestingly, not everything on a rogue planet has to be completely dead. Beneath the thick ice, deep inside the planet, heat can still exist. That heat comes from two main sources. First, leftover heat from the planet's own formation billions of years ago, when matter collided and compressed, generating extreme temperatures that have still not fully dissipated. Second, heat generated by the decay of radioactive elements inside the planet's core, a slow but continuous process that lasts billions of years. Thanks to these two sources, some scientists believe that rogue planets roughly the size of Earth, or larger, could sustain a liquid ocean deep beneath their icy surface, similar to how some moons in our own solar system, like Europa, one of Jupiter's moons, are believed to have subsurface oceans beneath a thick icy crust. If that is true, then a rogue planet, despite having no sunlight, might still hide a warm, dark, and quiet world deep beneath its permanent frozen surface. That radioactive heat comes mostly from the decay of uranium, thorium, and potassium, elements naturally found in the rocky core of most planets. On Earth, this same heat source, combined with leftover formation heat, has kept our planet's core molten for over 4 billion years, continuing to power geological activity like volcanoes and plate tectonics. A rogue planet roughly the size of Earth would carry a similar amount of these radioactive elements, and could therefore sustain an internal heat source for billions of years in much the same way. There is another factor worth considering here. Pressure. Deep inside a planet of any real size, pressure builds enormously, layer upon layer of rock and ice compressing everything beneath it. That pressure alone can keep water liquid at temperatures that would freeze it instantly near the surface. You are lying very still now. The day has grown distant. The thoughts that pressed close earlier have begun to soften at their edges. Your breathing has found its own pace. Slow, easy, unhurried. And as you rest here, I want you to imagine a planet drifting very slowly through the black space between two distant stars. There is no sound, because space carries no sound at all. There is no light falling on its surface, except the faint glow of stars very far away. That planet has been drifting like this for millions of years. It is in no hurry to get anywhere. It has no destination. It is simply moving at exactly the speed it gained the moment it left its mother star, a very long time ago. Its surface is covered in ice. Quiet. Still. No wind, because there is no thick enough atmosphere to create any. No waves, because any ocean that once existed froze solid long ago. Only stillness, stretching all the way to the horizon and far beyond it. Imagine you are floating gently just above that surface, weightless, silent, wrapped in soft darkness, like a warm blanket, with no light to disturb your rest, no sound to pull you back to the thoughts of the day. This rogue planet drifted here before humans existed on Earth, and it will keep drifting long after everything we know has changed. It does not worry about time. It does not count the years passing. It simply exists in complete peace within the endless space around it. And you, right now, can borrow a little of that peace too. Let your body sink deeper into your bed. Let every tension drift away from your shoulders, just like that planet drifted away from the light of its mother star, slowly and gently, without pain, simply letting go and letting things unfold naturally. There is nothing you need to do right now. There is nowhere you need to go. Just this soft darkness and your own slow breathing, blending together like that planet blending into the quiet stillness of the vast universe. Far, far behind that planet, there is a faint band of light stretching across the sky, the combined glow of billions of other stars in the same galaxy, too far away to appear as separate points. Just a hazy streak of light drifting through the darkness like a river made of starlight. The rogue planet drifts below that streak, small, silent, unnoticed by anything. And you too can feel that same smallness, not as something frightening, but as something deeply relieving. There is a certain freedom in being small in a picture this large. The worries that felt so pressing earlier today do not carry the same weight when placed next to a planet drifting silently through billions of years of empty space. Let that feeling spread through your body now, down through your chest, down through your arms, down through your legs, heavy, warm, sinking into the mattress beneath you. Exactly like that rogue planet sinking into the calm of its own endless drift. The idea that a rogue planet could hold life might sound hard to believe. No sunlight means no photosynthesis, in the way that plants on Earth use it to generate energy. But life does not necessarily depend on sunlight. On Earth itself, we have found ecosystems that exist entirely in darkness, deep on the ocean floor, around hydrothermal vents where hot, mineral-rich water escapes from the earth below. There, bacteria use chemical energy from compounds in the water instead of sunlight to build nutrients. And from those bacteria, an entire complex food chain has formed, including giant tube worms, crabs, and many other creatures, all living without a single ray of sunlight ever reaching them. If a rogue planet has a liquid ocean deep beneath its icy surface, sustained by geothermal heat from its core, then in theory a similar ecosystem could exist there too. No light, no sky to look at, but liquid water, heat, and complex chemistry. 3 ingredients that many scientists believe are necessary for life. This remains only a hypothesis. We have never directly observed the surface of any rogue planet, let alone search for life beneath its ice. But this hypothesis opens up an interesting possibility that life in the universe might not need a star at all. It could exist in permanent darkness, nourished not by light from outside, but by warmth from deep within the planet itself. If this is true, then the number of places that could hold life in our galaxy would be far greater than we once thought. because we would no longer only be searching for planets located within the habitable zone around a star, but also considering billions of rogue planets, each one potentially hiding a warm, quiet, dark ocean that may, right now, be nurturing some form of life we have never encountered. Hydrothermal vent ecosystems on Earth's ocean floor were first discovered by scientists in the late 1970s. Before that discovery, no one believed that life could exist at such depths, in complete darkness, under the crushing pressure of the deep ocean. But when researchers first sent submersibles down to that depth, they found a thriving world full of life, completely unlike anything they had imagined. That discovery changed the way biologists thought about the limits of life. It showed that sunlight is not an absolute requirement for life to exist and thrive. The bacteria there use a process called chemosynthesis, converting hydrogen sulfide and other chemicals released by the vents into usable energy, without any need for light at all. Some of these ecosystems are thought to resemble conditions that may have existed on the early Earth, before photosynthesis ever evolved, raising a fascinating question. If life on Earth could begin in total darkness, why should we assume that life anywhere else requires a star? A few rogue planets have already been identified and given specific names by scientists. One of the most famous cases is an object called CFBD SIR 2149. This object was discovered about 130 light-years from Earth, and initially scientists were not sure whether it was a giant planet or a type of brown dwarf, an in-between object between a planet and a star. It has a mass roughly 4 to 7 times the mass of Jupiter and drifts freely, not orbiting any star. Another well-studied case is an object called PSOJ 318.5-22. This object also has a mass equivalent to a few times the mass of Jupiter, and scientists have been able to observe its atmosphere in detail because it is not obscured by the glare of a nearby star. This is quite interesting, because normally studying the atmosphere of a planet orbiting a star is very difficult, due to the star's light being far too bright compared to the light reflected by the planet. But with a rogue planet, there is no star for comparison, so scientists can observe the faint infrared light given off by the planet itself, and from that analyze the composition of its atmosphere. These observations showed that PSOJ 318 has an atmosphere filled with clouds, similar to those found on the giant gas planets in our own solar system. Studying rogue planets close to Earth, like these two examples, allows scientists to better understand the formation and structure of giant gas planets in general, without interference from the radiation or gravity of any host star. In a sense, these rogue planets act like natural laboratories, letting astronomers observe a planet in something close to its purest state. Observing these planets is typically done using telescopes capable of capturing infrared light, a wavelength invisible to the human eye but rich with information about the temperature and chemical makeup of an object. Rogue planets, though they have no sunlight to reflect, still emit a small amount of infrared radiation from leftover heat generated during their formation. The younger a rogue planet is, the hotter it tends to be, and therefore the easier it is to detect through its own infrared glow. Older rogue planets have cooled considerably over billions of years and become far fainter, much harder to spot using this method. That is why the first confirmed rogue planets tend to be relatively young ones, sometimes just a few tens of millions of years old. Beyond CFBD SIR and PSOJ 318, astronomers have cataloged several dozen other free-floating candidates in nearby star-forming regions, clusters, where young stars and young planets are still emerging together from the same collapsing clouds of gas and dust. There are several ways a planet can end up wandering alone. The most common way, as we discussed, is being ejected from its own planetary system through gravitational interactions with other planets. But there is another way, just as interesting. Some planets may form without ever needing a star at all, from the very beginning. When a massive cloud of gas and dust in space begins collapsing under gravity, most of the material gathers into a star at the center. But sometimes smaller fragments within that same cloud can also collapse on their own and condense into a separate object with a mass equivalent to a giant gas planet, without ever gathering enough material to become a star. This object never had a host star to orbit. It was born independently from the very first moment and has drifted freely ever since. Astronomers sometimes call these objects free-floating planets by birth, to distinguish them from planets that once had a host star but were later ejected. Telling these two types of rogue planets apart is not easy based on observation alone. Both types drift in darkness, emit no significant light, and have fairly similar chemical compositions. Scientists have to rely on indirect clues, such as the object's age, its mass, and its position within the galaxy, to make educated guesses about the true origin of each individual rogue planet. Another interesting point is that the boundary between a planet and a brown dwarf is also quite blurry. Brown dwarfs are objects with mass greater than giant gas planets, but smaller than a true star. Not massive enough to sustain hydrogen nuclear fusion at their core, the way a real star does. Many objects discovered drifting freely in space fall right at this blurry boundary, forcing scientists to debate whether to call them giant planets or low-mass brown dwarfs. This debate reflects a deeper truth about the universe, that nature does not always sort things neatly into the categories humans create. The boundary between a giant gas planet and a brown dwarf is usually set at around 13 times the mass of Jupiter. Above that threshold, an object has enough mass and internal pressure to begin nuclear fusion of a hydrogen isotope called deuterium, even though it is still not hot enough to sustain ordinary hydrogen fusion like a true star. Below that threshold, the object is considered a planet, whether it orbits a star or drifts freely. That mass boundary is not a hard physical wall. It is a convenient marker, agreed upon by the scientific community for the sake of classification, rather than an absolute line that nature itself strictly obeys. Adding to the confusion, some brown dwarfs are found orbiting stars just like planets do, while some genuine planets are found completely alone, blurring the line even further. A telescope named the Nancy Grace Roman Space Telescope, expected to launch in the near future, is hoped to revolutionize the search for rogue planets. This telescope is specifically designed to carry out large-scale microlensing surveys, observing hundreds of millions of stars continuously for years. Scientists estimate that this telescope could discover thousands of new rogue planets, including smaller ones roughly the size of Earth, or even smaller than Mars. This would be a major step forward compared to previous surveys, which were mostly limited to detecting larger rogue planets, roughly the size of Jupiter or bigger. Detecting smaller rogue planets closer in size to Earth is especially important, because those are the planets most likely to have rocky surfaces and possibly subsurface oceans beneath an icy shell, as we discussed earlier. If the universe truly is filled with small, Earth-sized planets drifting freely with no host star, this could become one of the most important discoveries in modern astronomy, opening a new chapter in the search for life beyond Earth. Beyond the Roman telescope, scientists are also developing new methods for detecting rogue planets, such as searching for faint infrared light given off by leftover heat inside young planets recently ejected from their systems, before they cool down completely. Combining multiple methods together promises to gradually uncover the mystery of the true number and diversity of these lonely worlds drifting throughout our galaxy. The telescope is named after Nancy Grace Roman, a woman often considered the mother of the Hubble Space Telescope program and one of the pioneering astronomers at NASA. This new telescope is equipped with a field of view roughly 100 times wider than the Hubble telescope, allowing it to scan a large area of sky in far less time. For the search for rogue planets, this capability is especially important because scientists need to monitor hundreds of millions of stars at once, over many consecutive months, to have a chance of catching these rare and brief microlensing events. Beyond the Roman telescope, several ground-based projects are also being upgraded with wider cameras and faster processing systems to catch more of these fleeting signals in real time. Scientists are also exploring the use of artificial intelligence to sift through the enormous flood of data these surveys produce, automatically flagging unusual brightness changes that a human researcher might otherwise miss. This combination of bigger telescopes and smarter software is expected to push the field forward faster than at any point in its history. Where once a single rogue planet detection might take years of careful analysis to confirm, future surveys may identify dozens, or even hundreds of candidates in a single observing season. There is a striking contrast worth thinking about between a rogue planet and Earth, the place we call home. Earth is warmed every day by the sun. We have sunrises. We have sunsets. We have 4 seasons, cycling every year, bringing change and rhythm to the life of every living thing. A rogue planet has none of that. No sunrise to wake it up. No sunset to lull it to sleep. Only one single state, unchanging, stretching across billions of years. But perhaps precisely because of that, a rogue planet also does not suffer the instability that many other planetary systems experience. It does not have to worry about radiation from a nearby star suddenly flaring up and stripping away its fragile atmosphere. It does not have to worry about its host star one day swelling into a red giant and swallowing every planet in its close orbit. A rogue planet has already escaped all of those risks. It simply drifts in stillness, threatened by nothing except the sheer vastness of space itself. There is a strange kind of peace in that thought, that sometimes escaping a system, even one that once provided light and warmth, can also bring a different kind of freedom. A rogue planet is no longer bound by the cycle of any star. It no longer has to spin according to a rhythm imposed from outside. It simply exists in its own way, in the darkness that it either chose or was handed by fate a very long time ago. Many planets orbiting other stars, especially small, cooler stars known as red dwarfs, face a constant threat. These red dwarf stars, despite being small, tend to release violent, unpredictable bursts of energy far more often than our own sun does. A planet orbiting too close to such a star can have its entire atmosphere stripped away after just a few powerful flares, repeated over millions of years. This is one of the biggest challenges scientists face when searching for potentially habitable planets around red dwarf stars, which happen to be the most common type of star in the galaxy. A rogue planet entirely avoids this risk. There is no nearby star to release dangerous flares like that. Its atmosphere, if it has one, will not be eroded by stellar wind or intense ultraviolet radiation. There is a certain irony worth sitting with here. We often assume that having a sun is purely a benefit: warmth, light, energy, the foundation of everything we associate with the living world. But every star also carries risk, a constant, low-level danger that comes bundled together with its warmth. A rogue planet gave up the benefits of a star, but in doing so, it also walked away from every one of those risks. It traded warmth for permanence. What is the final fate of a rogue planet? This is a question scientists are still trying to answer. Unlike a planet orbiting a star, which might eventually be swallowed by that star as it ages and swells in size, a rogue planet has almost no clear ending point at all. It will keep drifting through the galaxy for billions of years, trillions of years, far beyond the current age of the entire universe. Throughout that journey, the odds of it colliding with another object are close to zero. The space between stars is so vast that even if the galaxy contains billions of rogue planets, the average distance between them is still far greater than the distance between Earth and the nearest star. A rogue planet could drift through the entire remaining history of the galaxy without ever coming close to any star in any meaningful way. Over time, the stars we see in the night sky will gradually run out of fuel. Some will become faint white dwarfs. Some will explode as supernovae. But a rogue planet, depending on no star at all, will not be directly affected by any of those events. It will simply continue drifting, keeping the same orbit and speed that it gained a very long time ago, almost unchanged across timescales so vast they are difficult to truly comprehend. Some astrophysicists have thought about what will happen in the far distant future of the universe, when most stars have gone dark and the galaxy is left with only dark remnants of dead stars. In that distant picture, rogue planets could be among the most durable structures still remaining, drifting among the remnants of an aging universe, carrying, perhaps, beneath their ice, oceans that are still warm, sustained by heat from their own core. Physicists estimate that the smallest, coolest red dwarf stars could continue shining for trillions of years, far longer than the current age of the universe. But even those long-lasting stars will eventually run out of fuel and go dark, leaving behind a galaxy that grows darker over time. In that distant era, scientists sometimes call the age of black dwarfs. Hardly any new light will be produced from new stars, because the material needed to form stars will also gradually run out, leaving a galaxy that grows quieter and darker with every passing eon. Yet even then, rogue planets will likely persist, unaffected by the fading of starlight, since they never depended on it in the first place. They will keep drifting through that darkening galaxy, carrying, in some cases, their hidden oceans, still liquid, still warm, sealed beneath ancient ice, long after every star that once illuminated the sky above them has gone silent. Studying rogue planets also offers an important perspective on how planetary systems in general form and evolve. For decades, scientists could only study one planetary system in detail. That was our own solar system. But our solar system may not be a typical example of how every planetary system forms. The discovery of thousands of planets orbiting other stars over the past few decades, along with the discovery of so many rogue planets, has shown that the process of planet formation is far more diverse than scientists once thought. Some planetary systems appear stable from the very beginning, keeping the same orbital structure for billions of years, similar to our solar system. But many other systems go through a chaotic phase lasting millions of years, during which planets compete for orbital position, collide, and sometimes push each other out of the system. The large number of rogue planets discovered suggests that this chaotic phase may be more common than starting out stable from the beginning. This means that our own solar system may have once lost one or more planets during its early formation, billions of years ago. Some scientists have proposed a hypothesis that there may have once existed a fifth giant gas planet in the early solar system, alongside Jupiter, Saturn, Uranus, and Neptune. But that planet was ejected during an early, chaotic gravitational interaction and is now drifting freely somewhere out there in interstellar space, possibly thousands of light years from Earth. This hypothesis was first proposed to explain certain unusual features in the current orbits of Uranus and Neptune, features that computer simulations struggle to recreate accurately if only 4 giant gas planets existed from the very beginning. When scientists added a fifth planet to their models, with a mass comparable to Uranus or Neptune, and allowed it to be ejected during the early chaotic phase, the simulations recreated the current orbital structure of the solar system much more accurately. This is not direct proof that such a planet actually existed, but it is a compelling suggestion that the story of how our solar system formed may be far more complex than what we observe today, with only 8 planets remaining. If a fifth giant planet really did once exist, it would have carried its own moons along with it, at least for a while, though most would likely have been lost or scattered during the ejection itself. That lost world, if it exists, has now spent over 4 billion years drifting somewhere among the stars, carrying, quite literally, a piece of our own cosmic history that no telescope has ever confirmed finding again. There is something worth reflecting on about the distance between a rogue planet and anything else. In interstellar space, distance is not measured in kilometers or miles. It is measured in light years. The distance light travels in 1 year, at a speed of roughly 300,000 kilometers per second. Even at that speed, light takes more than 4 years to travel from the sun to the nearest star. A rogue planet, drifting somewhere in the middle of that space, far from every star, may not see a single light source close enough to create even a hint of daylight on its surface. The sky of such a planet would simply be a black curtain, dotted with tiny points of light very far away, stars whose light took decades, centuries, even thousands of years to arrive there. This isolation is almost impossible for humans to imagine. Creatures that evolved under sunlight and the rhythm of day and night throughout our entire history. But perhaps it is exactly that difference which makes the image of a rogue planet feel especially peaceful when we think about it before falling asleep. It has no deadline to meet. It has no alarm clock to hear. It has no harsh light to disturb its rest. It only has endless darkness and complete stillness of deep space. To picture this distance more clearly, imagine this. If the sun were shrunk down to the size of an orange, placed at one end of a football field, then Earth would be a tiny grain of sand just a few meters away. And the nearest star, at that same scale, would be thousands of kilometers away on another continent entirely. A rogue planet drifting somewhere in that space would be completely isolated, with no orange close enough to warm it. This isolation means a rogue planet is almost untouched by anything from outside. No asteroids regularly striking it. No radiation from any star reaching it. It exists in a kind of complete isolation that not even the most remote places on Earth could ever compare to. Somewhere out there in the universe exists a state of being completely undisturbed, not because it has been abandoned, but because it never needed anything from outside in the first place. There is a quiet dignity in that kind of self-sufficiency, existing entirely on its own terms, unaffected by the noise and expectations of the world around it. A rogue planet does not check if anyone is watching. It does not wonder if it matters. It simply continues its slow drift, content in a manner that requires no witness, no audience, no approval from anything beyond itself. As we gently come toward the end of our time together tonight, let us think about what it means to wander alone. A planet that once might have belonged somewhere, that might have once circled a warm star under steady light every single day. But for some reason, a collision, a pull, a chaotic moment long ago, it was pushed out from that place forever. For humans, losing something familiar, a place, a connection, usually brings a feeling of loss, a feeling of emptiness. But a rogue planet carries none of that emotion. It does not remember the star it once orbited. It does not grieve the light it once had. It simply continues drifting, adapting to its new state, not through effort, but through its own physical nature. It exists in the way that gravity and momentum shaped it to be. There is a gentle lesson hidden in that story, that sometimes leaving a familiar orbit, no matter how painful or chaotic that moment feels, does not necessarily lead to destruction. Sometimes it simply leads to a different state, a different way of existing, not better, not worse, just different. A rogue planet does not try to find its lost star again. It does not rush off searching for a new source of light. It simply drifts along the path that physics has laid out for it, accepting darkness as a part of its existence, not as a punishment, but as its own natural state. Interestingly, a rogue planet does not need to prove its worth to anyone. It does not need a star to confirm that it exists. It does not need a named orbit to have meaning. It simply exists according to its true nature, whether anyone sees it or not, whether anyone knows it exists or not. Its value does not depend on being recognized from the outside. This might be one of the quietest lessons the universe has to offer, that existence itself is already enough meaning, without needing to be confirmed by the light of something else. As you prepare to fall asleep tonight, perhaps you too can borrow a little of that self-acceptance. You do not need to do anything more to deserve this rest. You do not need to prove anything to anyone right now. You do not need to earn the softness of this moment, the way a rogue planet does not need to earn its right to keep drifting in peace. You are simply allowed to exist in this quiet for as long as you need. Let your breath carry you a little further into rest. Let the weight of today dissolve, the way starlight fades slowly behind a horizon that no one is watching. And let yourself drift gently, without effort, without direction, towards sleep. The same way a lonely world drifts through the endless dark, patient and unhurried. As we slowly drift back from that black expanse between the stars, from the image of planets wandering with no sun and no sky to look up at, let everything we explored together tonight settle gently into your mind. We began with worlds that circle no star at all. We learned why they get ejected from their own systems during the chaotic early stages of formation. We learned about how scientists find them through the phenomenon of gravitational microlensing, catching a single flash of light that appears then disappears. We considered the possibility that a warm ocean might exist deep beneath the ice of a rogue planet, nourished by heat from its own core. We met specific examples, planets that have already been named, drifting tens to hundreds of light years away from us, and we reflected on the long-term fate of these worlds, continuing to drift across billions of years throughout the distant future of the universe. Through all of it, one idea remained, that solitude does not necessarily mean the end. A planet cut off from the light it once knew continues to exist in its own way, carrying a little warmth from within, drifting calmly through the stillness of space. There is nothing more you need to hold on to tonight. Let that planet continue drifting in its darkness. Let whatever thoughts remain from today drift away too, just as gently. And let yourself sink deeper into a slow, unhurried sleep of your own. The universe keeps drifting out there, but right now there is nothing you need to worry about. Just rest. Just stillness. Just you. Exactly where you are meant to be. Remember, wherever you are right now, however your day unfolded, you deserve this full, complete rest. Just like a rogue planet needs no proof to keep drifting in its own peace. You do not need to do anything more to deserve the sleep waiting for you right now. There is nothing left to solve tonight. There is nothing left to plan. Just this quiet room, this soft dark, and the slow rhythm of your own breathing, carrying you gently further and further from the day that has already let go of you, even if you have not quite noticed yet. If you are still here with us, another quiet journey is waiting for you. And if tonight's journey helped carry you closer to sleep, a like, a subscribe, or a gentle comment helps other tired minds find their way here too. From the Sleep Journal, and from one tired mind to another, across the soft, patient dark of tonight. Sleep well, rest gently, and good night.